Scientists are interested in glasses, not drinking glasses. Glasses are a state of matter that share properties with both liquids and solids. While solids tend to organize themselves in neat, tidy crystalline structures, glasses organize themselves randomly, in unique and liquid-like ways. NASA Glenn Research Center in Cleveland, Ohio, together with its partners at the New Jersey Institute of Technology and New York University, are probing this rediscovered state of matter on the International Space Station and rewriting the textbooks of soft matter colloidal physics. While many still labor under the myth that glass is a liquid, movement even on geological timescales would be hard to measure. What glass does seem to be is an amorphous solid, other examples of which include plastics, gels, and rubber. We have, of course, used glasses in bottles, window panes, and cell phone screens for many years. But even as we have tamed the structural use of this material, how it forms still holds mysteries. To unravel these mysteries, NASA researchers tried something new and quite interesting. They changed the parameters of this experiment by using oblong-shaped, micron-sized plastic particles mixed in a colloidal suspension. They changed the shape of the particles by stretching the spheres into ellipsoids. This enabled measurement of motion in new ways, both rotational motion of the particles as well as translational motion of the particles. Side-to-side motion could also be detected as the crystalline structures randomly formed. To this point, only textbook particles had been used in experiments, or particles uniform in size and shape. The oblong-shaped particles better resemble the natural world. On Earth, particles of this size would be invisible, and if you could see them, they'd sink due to gravity. Microgravity aboard the ISS offered the opportunity to observe these changes in real time in the light microscopy module, using easily observable particle sizes in real time. What the researchers found was that when a certain density of these ellipsoidal particles were suspended in a solvent, they formed a glass. The ellipsoidal particles in these rigid structures couldn't rotate, making the solution appear to be a solid, but strangely they could translate side to side, acting as if in a liquid. A literature review revealed a decades-old paper that predicted this phenomenon. The paper did miss some elements of the recent discoveries, such as like particles bunching together and others intersecting and growing at random angles. Maybe that's why glass forms random shapes as it cools. These discoveries and NASA partnerships are seeding new chapters in future textbooks.